Hi, in this video I will show you how to make a layout for an inverter. We will use for that KLayout open source tool and also IHP PDK for that. This IHP PDK has been already chosen, so we see that on the top here. So let's make a new layout, and let's make the database unit 0.05 micrometer, and in KLayout we can select the two transistors from the library. So I want to show you another way to make layout in a simple way. We do that with instances and select the IHP library. With the search indicator we can select the NMOS transistor and place is on the bottom, escape, and select the second one, also PMOS transistor, on the top, escape. To look into this rectangle and show all the layers, we can simply hit this up button to show the another layers. So now we need to align these two transistors so that the gate of these both transistors are in the same line. For that, choose the let's make a in another way. Let's hit on the PMOS transistor and hit Q for properties and see what is inside of the PMOS transistor. Go to the cell parameters and look into it. So in the IHP we are not able to make a bulk connections, so we can only change the width or the length of the transistor and also the number of gates or fingers, but we are not able to make a guard rings or bulks. So okay, let's leave it as it is, and we can simply align these two transistors to each other. So for that, let's hit on the NMOS transistor and click to move that. So we are able to move the bottom one, and simply with mouse we can zoom in, align them, and with the keyboard go to the bottom with sufficiently large distance from each other. So I think it is enough so that they are apart from each other. So now we can select, let's minimize these available layers to only this one. They are already existing on these canvas, and we can make the connections. So for that, hit gate poly drawing, hit box, and connect this two transistors together with the poly. And now we can switch to the Metal 1 drawing and make the same thing for the gate and source also. So that is the drain of these two transistors, and for the source we can make connection here as well as here. So now we can, on top of this drawing, make a pin connections as well. So select the Metal 1 pin and make a pin layer on top of this Metal 1 layer, and make the same thing for the gate. And now we can go again to the Metal 1 pin and hit text for add the pins for these transistors. Simply rename it and make a VN also. I use a remote connection for this video, so my computer is a little bit slower sometimes. Okay, but it works. So make the Y, the output connection as well here, and select gate poly pin, go to the text and change it to A. So now we are done with the pin connections for the inverter, and let's go to the tools and make a DRC check. So we have some issue. Let's go into it and see. So the global activity density is not sufficient. Go to the another one. Coverage ratio of any chip area is also not sufficient. Also, this density errors, there are only the density errors which we can ignore for this in this particular layout. Okay, there's something goes wrong. Let's save the this layout and as GDS, save. Okay, and let's close this and open it again. GDS. Okay, fine. So there are only some density errors which has been appeared in this layout, which we can ignore for this in this particular case. We will check the DRC LVS on the later next video. I will show you how to use IIC OSIC multi-tool for that. We will test this inverter, which has been made in KLayout, and also another one which we have already done with Magic. And let's see which of that has DRC errors, which one doesn't, and simply compare these two. I will show you this in the next video. So